Hello, everybody. Welcome to the first session of Quick Take to Machine Learning. I'm Eugene, one of the TAs of CS344. So over the next few weeks, I will be recording these Quick Take sessions to talk about random machine learning ideas that are outside the scope of the syllabus. So for this week, I will be talking about the role of mathematics in machine learning. In particular, I will explain how calculus and probability theory plays a role in many of the machine learning ideas that you will see throughout this module. Let us begin. All right, so let us begin with a simple problem. Right, suppose we are given 40 meters of fence. And what we want to do is to create a rectangular parameter. Right, we want to create a rectangular parameter such that the area enclosed by this parameter is maximized. So how do you do something like that? Well, if you recall back to your secondary school mathematics, a way that we can approach this problem is to just say that, well, we do not know this length. We want to find what this length x is. But if this length is x, we know in a rectangular, this would be x2. And similarly, this would be 40 minus 2x divided by 2, which you can simplify it to be 20 minus x. Right? And then what you want to do is to find what is the maximum area. So we use the calculus. We say, all right, let's take the area with respect to x. Right? So the area of this rectangle, given a choice of x, is x times 20 minus x. Right? And if you try to solve this, what you get is in fact 20 minus 2x. Right? Derivative of 20x is 20. Derivative of negative x squared is negative 2x. And then what you do is to just set this derivative to 0. Right? We know that this will give you a critical point. Right? And in this case, it turns out that this critical point is going to be the maximum point. Right? So if you set this to 0 and you solve this equation, you solve 20 minus 2x equals to 0, what you will find out is that the optimal x that we want is x equals to 10. All right, so let us think about what we have just did in a more general sense. All right, so this is a very typical optimization problem where we have some kind of a variable, which is here, which is the x here, that we can change, right? So we call such a variable in machine learning context, we call such a variable a parameter, okay? And what we have is that by changing this parameter, it will result in a change of some other function, right? In this case, it will result in a change of this area function. Now, in machine learning, we call this particular function the objective function. Okay. So the goal in this simple optimization problem is this. We want to choose a value of x. We want to choose the value for the parameter such that the objective function is maximized, right? So written more generally, one can write this as a problem where we want to try to find a value of x such that some objective function f of x is being maximized. In particular, we want the value of x itself, right? So the optimal value of x is simply just the argmax of f of x. So this is the form of the optimization problem that we have right here. And since f is differentiable in this case, we just take the derivative, set it to 0, and we are done. So this is a simple problem. What I want to do is to show you how this is played out in one of the simpler machine learning algorithms called linear regression. Let's do it now.